In this section, we're going to look at partial variations. So you just looked at direct variation. Partial variation is similar, but not exactly the same as a direct variation. So a partial variation is similar to a direct variation in that it is a linear relationship, which means as the x values or the independent variables increase, the y values increase as well by a constant amount. So for example, if I add 2 to the x value every time and 3 to the y value every time, those values, those jumps are constant. And so it's a linear relationship. Where a partial variation and a direct variation change is that 0, 0 value. So if you remember in a direct variation, it needs to start at that 0, 0 point. In a partial variation, it doesn't start at 0, 0. There is some value in the dependent variable, the y space, when x is 0. So let's look at an example. Colton repairs heating and air conditioning systems. When he's out on the service call, he charges a service fee of $75 plus $65 per hour for labor. What are the initial value and the rate of change? So the initial value would be how much he would charge as soon as he walks in the door before he spends any amount of time there. And that would be the $75 service fee. And then the rate of change would be how much the price increases per hour in this case. And he charges, sorry about that, $65 per hour. So that would be your rate of change. So for every time the hour increases by 1, the cost increases by 65. So the rate of change is $65 per 1 hour. Okay. Create a table of values for the cost for 0 hours right up to 5 hours. And how does that table show the initial value and the rate of change? So I'm just going to grab a table that I already created here and show you how that stuff is read. So for 0 hours, it would cost $75. That's the initial value. And for every hour after that, it would be an additional $65. So for 1 hour, it would be $140. 2 hours, it would be $205. 3 hours, $270, and so on and so forth. So the initial value is this cost at 0 hours, right? It costs $75 at 0 hours. And the rate of change is how much the amount charged is increasing as the time increases by 1. Okay, so it's really important that the time is increasing by 1. So that means that the 65 is our rate of change. Predict what the graph and the table of values would look like. Sorry, graph of the table of values would look like. So we know that because we're going up by the same amount every time, it would be linear. So the graph would be a straight line. But where normally it starts at that 0, 0 point, way down in the corner of the graph, this one would start at 0 and 75, a little bit higher up. So it would start at 0.75, and it would increase by 65 every time. So every time we go up by 1 hour, the amount would increase by 65. So it would look something like this, where this is the $75, and then we would go over 1 and up 65, something like that. So what does Colton charge for a job that takes an hour and a half? So that would be right in between 140 and 205, right? So what I would do to find that is I would do find kind of the average of the two. So I would do 140 plus 205 divided by 2. And we should get 140 plus 205. Sorry. So 140 plus 205 is 345 divided by 2, and it's 172.50. And explain why the cost of a 2-hour repair is not double the cost of a 1-hour repair. And that's because a 2-hour repair would be 2 times 65, because it's 2 hours and $65 an hour, plus the $75 service call fee, that initial fee. So this plus $75 makes it so that it's a little bit more than double the hourly rate. So it's that plus 75 that's constant throughout that makes it not double the cost. So some things to look at for the table of a direct variation. The initial value, that 0 in the independent variable, you shouldn't have 0 with it. So you shouldn't have a 0, 0 point, but you should still increase by the same amount every time.